Hey, Plumber Tom here. If you're preparing for a plumbing state test or trying to improve your knowledge of code and understanding of plumbing, don't forget to check in the description below for links to study guides, online courses, and other resources that will help you to learn the code and pass your test. When you click on those links and purchase resources, you're helping me to be able to create more great content. Thanks for watching. NFPA 13D, standard for the installation of sprinkler systems in 1 and 2 family dwellings and manufactured homes. Hello, welcome to this presentation of the NFPA 13D. My name is Thomas, and in this presentation we're going to look at Chapter 9, which is specifically about protection from freezing.
Chapter 9, Protection from Freezing.
Once a fire sprinkler system has been installed, if the water inside that system were to freeze, it would be a catastrophic loss because it wouldn't be able to put out the fire even though you have the whole system. So we can't have it freezing up. There's a whole chapter here about our methods for handling these systems in freezing situations. So let's get into it, find out what it's all about. Join me at 9.1.1. We're going to talk about wet pipe systems. And once again, we're trying to protect these systems from freezing. And a dry pipe system is going to be less likely to freeze because there's no water in the system. But what if we have a wet pipe system? When can we use a wet pipe system? And when do we have to use a dry pipe system? Well, that is defined right here. It says for wet pipe systems, they are permitted where all the piping in the system is installed in areas not subject to freezing or insulated to maintain 40 degrees Fahrenheit. That's the cutoff temperature. That's the line. If it's 40 degrees or more in the building where the system is installed, you can use a wet system. If it's any less than 40 degrees for any reason on any part, even if most of it is in a non-freezing area, if any part of it reaches into an area that is less than 40 degrees, then we have to find some alternatives. But let's say that we're going to use a wet pipe system and we want to protect it from freezing. Of course, insulation is going to be a very important part of any building in maintaining what's called the thermal envelope. That's the heated space or conditioned space inside the building where we want to maintain a certain temperature for our own sake because it's comfortable. But if those systems are installed outside of that, say you've got fire sprinklers in the ceiling, they're going to pass through joists or trusses, and they're going to come down through the ceiling. Any attic space or areas like that would be subject to freezing or lower temperatures would have to be insulated. And in the appendix of this book, there are a number of illustrations with some good advice about the insulation to make sure that it's done in a way that it won't cause problems. So the first one, 9.1.1a, and again, you can turn to this in the back of your book. The first one says, caution, it is important that insulation be installed tight against the joists in unheated areas. Any spaces or voids between insulation and the joists causes the water in the fire sprinklers to freeze. So that batted insulation, if it's put into there, if there's any gaps that the air can get down to the pipe, at that point, it could freeze. So you have to make sure that insulation is fully covering from joist to joist all the way across. Blow-in insulation's a little bit easier because it just piles it in, right? And pound it in there. But particularly with batting, it's limited in its width and its length. You got to make sure it's all filled in. Another caution for areas having temperatures of 0 degrees, so we're talking really cold attic spaces or lower, an additional bat of insulation covering the joist and the fire sprinkler piping should be used. So now we're putting insulation down in the joist, then we're putting insulation over the top of the joist because we don't want that air to be able to get to the pipe, especially in those super cold spaces. Illustration C. If holes are drilled in the joist and the pipe is down in the joist that way, it says boring holes in the joist is one method of locating fire sprinkler piping in the ceiling. As an alternative, when temperatures are expected to be 0 degrees or lower, loose pieces of insulation should be stuffed in the bored holes around the pipe. So you're actually going down and pushing insulation into those holes. No, there's a couple of issues there. If you compress insulation, it does lose its R value, and then it's not as good of insulation. That means you're pushing it all together and the air comes out of it, and the more material on material that there is, the more, you can lose heat through the transfer of those materials. So, but they're saying this is better than nothing. Drill holes, put some insulation in, bat over the top of those. That can help keep it from freezing. It also says in point D, care should be taken to avoid compressing the insulation. That's the point I just made. You don't want to push it all down because it loses the R value. To prevent potential freeze-ups of sprinkler piping, the insulation should be installed tight against the joists, as mentioned before, but light and fluffy so that it maintains air, and that way the heat doesn't transfer through there, and then we get freezing. Point E says care should be taken to avoid compressing the insulation once again, but we see a difference in the orientation of the pipe. You see how this one's hung below and then it hooks over the top. And same basic point, but just a different way to run the pipe. And then we have illustration F. This shows a fire sprinkler coming down through a ceiling. The pipe is up above in that attic space, but they've put what they're calling a tent, some kind of a membrane that goes over the pipe that allows some of the heat from below to kind of surround in, give some air for that to surround in around the pipe, and then the insulation goes over the top. This is for blow-in insulation, and hopefully that's going to help keep these systems from freezing. So as a plumber, I'm looking at, we've got some pipe, and we're talking about putting insulation over it. Why not put insulation around it? That's what we do with our plumbing pipes, insulate the pipe if you're trying to maintain a heat inside the pipe or keep them from freezing. But think about this. If you have a fire sprinkler system, it's going to add a lot to the cost. While insulating may seem like a no-brainer, adding that sort of cost to the project unnecessarily is not going to work, especially if you can do a different system. Like we've talked about wet pipe systems, but if you can go to a dry pipe system, you don't have that cost in material. You don't have to insulate all the pipe, and that saves a lot of money. So you're pretty much never going to see insulation on, fire sprinkler pipe, but they have these other suggestions to use the existing insulation and try and keep them as free from freezing as possible without adding the cost of pipe insulation. That's kind of my take on this. So let's consider then, if we're not going to use a wet pipe system, what are the alternatives for systems that we could use if we know that these are going to be in spaces that are less than 40 degrees and we have to do something to keep them from freezing? Well, 9.1.2 gives us systems in areas subject to freezing, and here are some of the options. Number one, you can use a dry pipe system. That means the pipes are filled with air, and there's a dry pipe valve, and if any of the heads open up, the dry pipe system valve opens up and starts to let the water through. It's going to go directly to that head that's open and push through the system that way. So that's one option. Another option is you can add antifreeze to the system. So we are going to have liquid in there, but just pushing some antifreeze into that so that, it's never going to freeze out there. The third option that we are given is to use a standard dry pendant or sidewall sprinkler. And we looked at this in chapter 8 when we looked at these sprinklers that reach through, if you recall. These were the exposed barrel length dry sprinklers. So basically you've got the wet sprinkler system inside, and we've got a short dry piece of pipe that goes out to a sprinkler head into a space that is going to be lower temperature. That can work. The fourth option they give us is to add some heat tracing. That's some wiring that's going to keep the pipe warmer and to insulate. So I mentioned earlier, you don't usually see insulation on fire sprinklers. That's going to add a lot of cost, right? Heat trace and insulation, but it is an option. And number 5, residential dry pendant or sidewall sprinklers. Same sort of thing. You've got that dry sprinkler. It's got the barrel, but it's going to be the residential type of a sprinkler rather than your typical standard sprinkler. But those dry pipe with the barrel, those are options. In 9.2, it gives us some specifics regarding an antifreeze system and the antifreeze that would be used for that. First of all, it says that antifreeze would have to conform to local health regulations. What we're worried about here is the possibility of, antifreeze getting into potable, and we'll look at some designs for how to prevent that. But anyway, you've got that health regulation that's going to say, well, this is not going to work anywhere near, potable water. There are two options specifically listed for types of antifreeze in the NFPA 13D. One of those is glycerine. It's listed several times for different situations. But if glycerine is used, it's anywhere from 48 to 50% of the liquid is going to be that glycerine. And the other one is propylene glycol. And that one would range from 38 to 40% of the liquid is going to be that glycol. Anytime that antifreeze is used, we're required to leave documentation stating what that is and some of those specifics for the owner or user of the system. Now, if you're looking at Chapter 9, you'll see several diagrams here. Let's talk through these. This is 9.2.3.1, connection between antifreeze system and a wet pipe system. So we have a wet pipe system. We're going to put some antifreeze in some of the pipes that'll go out to the colder area. And in this diagram, there are no backflow preventers involved. Let me just take a time out here and say that for fire sprinkler code, that's one thing. For plumbing code, this would never be allowed, because when there's a crossover, a connection like this from potable to non-potable like this, we're putting glycol in, you have to have a backflow preventer. There's no other way around it. So to conform to plumbing code, we'd have to have a reduced pressure principal backflow preventer installed here, and this pipe diagram option is not really feasible. But let's look at it real quick anyway to see what they have on the fire sprinkler side on how you would pipe this. So you have the water supply coming in from the left, and they have a funnel or a cup on the top where that antifreeze can be added down in to the system. So, you got your valve is shut off to the water. You're pouring direct antifreeze into that system. It goes down into that U-shaped loop. We have what's called a drop. And all of this is happening in the heated area. That glycol solution is added. At the bottom of that drop, there's a check valve and a drain valve. Those are some controls so that, we don't get a lot of backflow coming in. Now, we say there's not a backflow preventer, but a single check valve doesn't count as a backflow preventer, even though it is capable of keeping fluids from moving the wrong direction. It's not a life-saving type of a backflow preventer. But we do have the check valve involved, and then there's a drain valve so that you can drain off that downstream side of the system. And then, of course, it goes up into the system and to the sprinklers. Let's look at the other diagram. We have 9.2.3.2. This is a connection between the antifreeze system and the wet pipe system on the warmer inside portion of the building. And this one does have a backflow prevention. So this is probably the right way to do this. You can see on the left, we have a backflow preventer. And then that moves forward. We have an expansion chamber. There is in this pipe configuration a way to put that antifreeze into the system. Once again, there's kind of a cup or a funnel on the top of a T here where you can just pour that right in. There's a drain valve in case you ever need to drain that down. And then from there, it goes out to the rest of the sprinklers. 9.3 gives us information on the dry pipe and pre-action systems. Now, these are both options where you have the pipe out there, it has air in it, and you're only going to release the water when one of the sprinklers opens up and then it starts to spray. You can see that on this diagram. You have the yellow is the air pressurized dry pipe system. So all those sprinklers out over that space are filled with pressurized air. And then down on the left, we have the water supply. So the water supply comes in. There's a fire connection. So if they want to increase the amount of water flow, they can hook up a fire hose on the outside and push some more water in. But above that, you have the dry pipe valve. And again, when a head opens up and air pressure is lost, then the dry pipe valve will open up and allow the water to push through to that head and put out the fire. Now, rather than go pop heads to test this system and make sure it works, there's also the inspector's test connection. Basically a pipe way downstream where you can just open a valve and it simulates the opening of a sprinkler head. So it opens up and the air flows out through the test connection, and then we can make sure that water would flow through as needed. So this is a basic dry pipe system. Here's an illustration of a combination wet pipe system and dry pipe system. So in one part of the building, then you have all of this wet pipe side. You have a pressure tank and a pump, lots of valves and controls and gauges, all that enabling the wet pipe side of the system. On the other side where we have the dry pipe system, there's an air compressor. It's pushing air into the dry pipe system side. And again, the dry pipe valve, a dry alarm, where if that opens up, it can immediately deliver water in place of the air, and that's going to put out the fire. So again, 9.3 talks all about the dry pipe and pre-action system. Here are some of the topics. I'm just kind of giving an overview without a whole lot of detail, but it does talk about the sprinklers that would go into a dry pipe system and the arrangement of those sprinklers. It talks about pre-action systems, location and protection of valves so that those wouldn't freeze. Detection devices, you want to know if water is moving and if it's putting out a fire. System configuration. It talks about drains and auxiliary drains as well as air supply. Now, a couple notes on that. They do in 9.3.7 mention that piping should be installed with a pitch minimum of 1/4 inch per 10 feet to facilitate draining. Now, think about plumbing drainage. We go 1/4 inch per foot, and they're doing 1/4 inch per 10 feet. This is very minimal slope. But what it does is it provides just enough of something so that if we have to drain down the whole system, we can get the majority of that water out and we're not worried about it freezing. Also, when it's talking about auxiliary drains, in 9.3.8.2, it says, at a minimum, auxiliary drain shall be a nipple and a cap or a plug of not less than 1/2 inch. So auxiliary drain means I can walk up to it and manually drain this down, but it has to be plugged so that I can't accidentally bump it and flood the whole place. So either a nipple with a cap or a plug and a minimum 1/2 inch size so that we can adequately drain that down. There is more in 9.3 than that. You might look over it and see what other details you can pull from there, but generally that's what this is all about in Chapter 9, maintaining the system so that it doesn't freeze, so that when there's a fire, it can function. Even in a freezing situation, it can push the water where it needs to be, whether that's a dry pipe system and we push the air out, or an antifreeze system and it splashes some antifreeze and then delivers water. Whatever the situation is, we want to make sure that when that system is needed, it can perform properly, deliver water, and put out the fire. Join me in the last presentation as we look at chapters 10 through 12. We'll finish off the NFPA 13D. I'll see you there.